This is a brief introduction to an online identity practice program for trigonometry. If you look at the screen, this is the screen you get when you open it up. You'll see on the left-hand side there's a mathematical expression, and then there's an equal sign, and on the right-hand side there's another mathematical expression. Essentially, the object of this lesson is how to use this program to prove that this side over here is equal to that side over there, and that's called solving the identity. In this particular case, in this particular program, you only work on the left-hand side. In other words, everything you do has to be on this side of the equation, and we keep working the equation until we, using algebra and trigonometric identities, make this side look like the other side. A couple of things I want to say quickly is that this says tan of x times secant of x times sine of x equals tangent of x squared. See the little caret there? That's a little upside down v, that caret. That's how you say, that's how you raise things to powers in this particular program. It uses the same kinds of syntax as a spreadsheet uses. So if you're used to using a spreadsheet, this will be fairly easy for you to do. Okay, so let's just solve this thing and see how it works. To begin with, you have a given, and you can change the given. You can press this button right here, which is start a new identity. Now watch what happens. See, I have a different identity and a different one. I can actually solve any of these identities that are in this list here. I'm going to go through them, and I'll come back to where I was before. There's only a few in here right now, but I'll increase the number shortly. So the first thing I want to do is I want to be able to work on this line, but I don't want to work it where it's given. I want to work it in line 1 down below. So what I do is I press the button called copy down, and it simply copies the whole line down. Now I can edit this line. You edit it just like you would edit anything. So in this particular case, this proof, what I want to do is I'm going to change all these functions over here into sines and cosines. That's one approach to solving these kinds of problems. So the tangent, first of all, right here, I'm going to change the tangent, and I'm going to say that really is the sine of x over the cosine of x. So I've just changed what the tangent is. The secant is, another way of saying the secant is 1 over the cosine of x. That's the secant. That's an identity. Both of these are identities. And a standard identity changes tangent to sine over cosine, and the standard identity changes secant to 1 over cosine. So now what I have is a new expression which contains sines and cosines, no more tangents and secants. The question is this expression, is it correct? So I press this button, test 1 over here, and down below, right now it says it's wrong, but see, it says the line 1 is good. The way I've rigged this program is I have it say that it is wrong to begin with, while the program goes to the server, does some calculations, it comes back, and eventually it will either end up saying the line is good or the line is bad. It's whatever happens last is what counts. So in this case, line 1 is good. Next step I want to do is I have sine of x in the numerator over here and sine of x in the numerator over here. So essentially what I have is sine x times sine x, or another way of saying that is sine x to the second power. That's sine x squared. Slash, and in the denominator I have 1 over cosine of x, so that's in the denominator, and sine of x here is over cosine of x, so that's also in the denominator. So what I really have is cosine x times cosine x in the denominator. Cosine of x squared. Is that a valid mathematical step? I go over here and press the test 2 button, and it says line 2 is good, so therefore that is correct. The next line I want to do is I know that the sine over the cosine is the tangent, therefore the sine squared over the cosine squared should be the tangent squared, which is what we're trying to show. We're trying to demonstrate that. Is it true? Press test 3, and I must have done something wrong. Yes, I did. Look over here. Instead of writing tangent, I wrote TIN. That's a mistake. And that's exactly what happens here. When you make an error, this thing says either your math is wrong, or your syntax is wrong, or the line, this line right here is not equivalent to that line up there. In other words, you didn't make a step that was correct. So now if I just edit this out and change this to tangent, like it's supposed to be, press the test 3 button, and the line is good. And that's it. I have therefore demonstrated that this identity is an identity. If I want to see what the page looks like, I can print it out. If you press this button, right here, I press this button, and it comes up with this new screen. And then I say, well, on the screen right here, if I right-click this new white screen and go down to print, what will happen is my print screen comes up. And when I press the button on the print screen, what will happen is this screen right here will print out on my printer, which it did. Okay, so let me just tell you how to get a hold of this program. It's located at this address. I'm going to write it right here on the right here in this space right here. It's http://dartworks.com/idrill.html. That's the program. http://dartworks.com/idrill.html, and you'll get this screen and you'll be able to work it. Okay? Good luck.